Good morning. Oops. Today we're going to just talk through some of the examples, the goods and the bads. And let's see, I'm starting with P2. By all means, if you can volunteer anything, let me know. Do you see anything right off the bat that struck me? My, right, personal pronoun right off the bat. Even before we get there, there's something. Where is it? All deliverables must use the report templates provided separately. Otherwise, you will get a 0 grade. Right off the bat, this is not in the report template. So the report template, this thing should look like this, right? With the title page and introduction, and right, so it starts with that, with the title page. And if you look, where are we? There we are. No title page. And no title, really, just project 2, you know, that's no good. So right off the bat, my. So let's take this. My final project will deal a lot with random number generation and with classes and creating new classes from those objects. That is what I call an informationally empty sentence. I learned nothing by reading it. So right off the bat, we've got my, which is a personal pronoun. It's the project. And we'll deal a lot. I don't know what a lot is. With random number generation, we don't know why. And then with classes and creating new objects from those classes, well, every project is going to have classes and creating objects from those classes because this is an object-oriented paradigm class. How about this next sentence? Anything that you could point out there? I'm going to ask y'all to review each other's work prior to submission for P3, not P2. So start thinking about this kind of, you know, this is how you can look at other people's work and how you can look at your own work. Besides the fact that we have a personal pronoun in there again, what do we got?
Very simple is unnecessary.
Very simple, right. So very simple is no good, right? What's the difference between simple and very simple? I'm okay with simple, but what's very simple? And RPG game. What do we know about acronyms?
Spell them out first.
Right. First use, spell them out. So this should be, you know, first of all, the first sentence can go away. The first sentence of this could have been something like, the project will be a simplistic role-playing game, parentheses, RPG. Ask yourself, every sentence that you write, after you write it, go back and reread it. What is that sentence doing? Does it have to be there? If I deleted that sentence, have I lost anything? It's really finely detailed, fine-grained inspection of your work. If I killed that sentence, right, what is it really doing for me? I'm going to come back to that in a backwards way before we're done. Third one, the game is a very similar basis to a game called Darkest Dungeon on Steam. It is a very simple game, but does its job well. What do we got with that sentence?
It needs to be quoted, and the second half of it can just go away.
Yeah, the second half can just go away. So Darkest Dungeon, he's referenced a commercial product, needs to have a citation and acknowledgement of that copyright. And we have the word very again. The game has a very similar basis, so you know, we can get rid of that. And yeah, a lot of that, very, very similar. Yep, yep. And the word basis, I think he actually wanted B-A-S-I-S, meaning the basis of something. You don't even have to say that. If it's similar to a game, say that. It's similar to a game. And then once he starts with that, I'm saying he, I don't know if it was a he or a she. And then on Steam, it is a very simple game, but does its job well. So that whole rest of that sentence is useless. I mean, it's not giving me information about the project. It's giving me information about Darkest Dungeon, but actually not much information, because if you're going to mention Steam, you better tell people what it is. I don't know what Steam is, right? Pretend your audience doesn't know. I don't know what Steam is. It's a very simple game, but does its job well. So again, we have very simple, and then we have it does its job well, which is, again, very subjective. I don't know what that means, that the game does its job well. So not only are those words not adding to the value of this report, they're not describing anything helpful about the Darkest Dungeon. I am planning to use the RNG element of the code. Again, we have an acronym that is not spelled out ahead of time. To deal with enemy random encounters throughout the game. That's pretty typical of you guys who are developing games. That's exactly how you should do it. But this thing, what to deal with, don't, if you're going to say that you're going to deal with something, you also have to say how it is going to be done. So for example, I still don't know, let's see what else we have here. The game is pretty much choosing, that's the whole description. The game is pretty much choosing a direction and heading that way. Okay. Again, notice how wishy-washy all the writing is, pretty much. Is it choosing a direction heading that way or not? So the game is choosing a direction heading that way. The random number generator will decide if you encounter any enemies or if you progress without any trouble. I can't say right now if there will be any graphics. Well, there's going to be some graphics because there's a GUI requirement on the project, or if it'll be all text. And that's fine too. You can still do text because as long as it comes through the GUI. I have to see how graphics are done when we get to that in class. And I asked them to think about what problems they're going to come up with. I think some of the problems are going to be making sure the RNG works properly and making sure the classes work together. They have not described the project, though, at all. Let's say they wanted to go with a text-based game. Now describe the functionality of the game. The user will be presented with a situation in text. The situation will describe, say, the environment they're in or a room that they're in, and any objects that they have in the room and any enemies that they encounter. The user can take the following actions. You know, run, pick up object, drop object, attack enemy, right? Let's say those are the only 4 options. Then you describe those 4 options in some detail, right? Not all of it's going to be necessarily laid out, but as much as you can. And the more you do it here, the better off your programming is going to be. Ideally, we would say the human or the player starts with 100 points of life. The enemies, there's 3 classes of enemies. One class has 30 points of life, and every attack it does 5 points of damage, or randomly between 5 and 10 points of damage. You can do that level of detail, and you absolutely should. By the way, I would put that kind of thing in a table. If you've got a player and 4 non-player characters, and you want to just list all of their properties, a table would be a natural way to do that. Players can move north, south, east, west. every move will take them to a different room or environment, or they will be presented with a new text. I'm just doing P2, so I'm not going to look at requirements now. We'll do requirements next time. Let's see, let's look at a better example. Let's try the bottom one, see what it says. Okay. Still not in format though. The wait time, oh, I think they're not in the format because I might have ripped them out of the, documents when I did this. The wait time manager is a program intended to monitor the wait time of a theme park attractions as its primary function. Okay, do we know what this thing is going to do? I have a pretty good idea here. The wait times and various data related to them archived for research and improvement purposes. Also included is a simulator to test the growth of wait times on the attractions in question. So I'm presuming that there's going to be a simulator that can dial up and down how busy the theme park is, let's say. So remember, try to say what and why right off the bat. And that's the what, and then the why is in here is talking about how the system can be inaccurate, where, you know, Disney tries to tell you how long you're going to be waiting in line, but that system can be inaccurate. And so they want to have an improved system. By the way, almost always you don't need to have so at the beginning, right? That sentence could start with, if an attraction has a posted wait time of 3 hours, it's likely that most people would be intimidated and averse to waiting. Now there's a quibble here. Let's pretend we got rid of so and we say, if an attraction has a posted wait time of 3 hours, it's likely that most people would be intimidated and averse to waiting. What's my quibble with that?
It's likely.
It's likely. Is that a claim? Did that sentence make a claim? Yeah. Now it framed it as it's likely, right? So if you're going to make a claim, you need to prove it. And really, this student may or may not have had access to data. I'm sure theme parks have data where they poll people, where they either poll people or they watch the behavior of their attractions, and they find out over time, okay, people are willing to wait a half hour for this ride, but they're willing to wait 2 hours for this ride, or that kind of thing. So if you can find data to back up the claim, that's good. If you can't find data to back up the claim, you really need to not put the claim in there. Now this person's going into what if scenario. So I'm not going to worry too much about the claim, right? It would seem a long time wait to correlates to reduction in growth of the line. That's intuitively makes sense, but just because something intuitively makes sense doesn't mean that we can say it. And then major measurement taken as the line was reducing. Now wait time of 3.5 hours gets posted, but the wait is actually dwindled to around 2. Really what he's talking about is back up here. The time being measured would be old. So there's a little bit of fuzziness in the writing, but overall, it's pretty clear what this person's getting at. And overall, the sentence structure is pretty good. You know, there's not sentence fragments, there's not run-on sentences. Then we get down to just quibbling about, okay, did you make a claim? Did you cite it? You know, are you clearly expressing this? Now,
so how detailed do we have to be with citing the claims? Like you said, in that first paragraph you have right there, wait times are measured directly by the time it takes. Is that like something that we'd have to cite as well?
Yeah, that's a claim. And that should be doable because that's something that theme parks actually advertise, right? And you can frame it that way. Walt Disney advertises that they will, publish wait times for their attractions. Or you can say from personal experience.
Okay.
Right? If you've been there and you know that's what it is, your personal experience is good. Then you don't necessarily cite it. You can say the author knows from personal experience, right? It's never me or I, it's the author or the project developers. But you can probably find some kind of Walt Disney advertising that talks about that, or some kind of measurement system.
I was just thinking you couldn't find something where they say that like their wait times are inaccurate.
Oh, right. So
from them at least.
Right. So the way you get around that is you say, you don't address that, and you say that you want to develop a system that is accurate. So you don't directly claim they're inaccurate. You say you want to develop a system that is accurate, or you want to study the effect of wait times on customer behavior by having virtual customers. Now, if you can find out that that system is a little bit inaccurate, if you can find the data, obviously, then put the claim in there. This notion of as the time being measured would be old, you would really have to have data on how often does Disney, for example, update their wait times. And I don't know. I suspect people have studied that and have published on that. Instead of operating directly on wait time, computer might measure a flux spin. One way to do so would be through turnstiles. Now here, see, turnstiles, which is intrusive and a nuisance for people entering the attraction. Uh-oh, there's a claim. So it would not be preferred. Radio frequency identification. Here, currently in use at Disney World is a device called Magic Band. All of these should be cited. So this person may work, I suspect they worked at Disney. But this Magic Band, I suspect you can find some kind of literature about that. And this person should have referenced that stuff. Okay, so we've got all this background information. That's great. Now let's find out see if we can find out what the project is. This is the problem statement. Yeah. So this person, maybe I should take it out of the good category and put it in the average category. I like the sentence structure. I like the fact that they know what they're doing. They seem to have an idea of what the problem they're trying to tackle. I'm not happy with the lack of referencing. And then, okay, now we have our description of the, so then we have a description of the program. Okay, so the program will be able to read the records of wait times, display useful information such as plot of wait time. Longest wait time, shortest time, plots such as longest time of day, that kind of thing. So that's good. You should, at some point, say specifically what plots you will do and you will not do. Second output file can be analyzed in various methods. Whenever you get various methods, by the way, whenever you're reading that, just perk your ears up. If they don't tell you what those various methods are, then it's really not quite complete. When I say a sophomore writing like this, can be analyzed in various methods to observe the error found in primary measuring system. I'm a little kinder than when I see a grad student writing like this. There's no way a grad student should say something like that, because instead of saying various methods, say the method. And then you've all taken statistics classes and things like that, so you can and had hopefully exposure to that. So you can specify it more clearly. My goal is to just get you as concrete as possible. Second output can be file. Let's see, how would you measure that? Whatever the error found in observing the primary measuring system. The errors you found in primary measuring systems tend to be, all you're going to do is you could easily say something like, at 30-minute intervals, we're going to compare the predicted wait time with the posted wait time, and then we're going to define the error to be the average of all the differences, the average of the absolute values of the differences. You can be that concrete. And my goal for you is to be that concrete ahead of time, again, so that once you start programming, you're not trying to solve the problem. If you don't know what statistical test you want to do here, just take this as an example, and you start programming, now you're solving two problems at the same time. What am I doing and how do I code it? You want to get the what am I doing out of the way first. If you know ahead of time, okay, I've got to do an average of numbers, now you know how to code it. It makes your job coding much easier.
If we're not 100% sure, should we just be concrete about it and go back and change it later?
Yes, and you can even note, this may be modified during the development process. It's okay to note that. Be as concrete as you can be. If you absolutely aren't sure, like in this sentence, this person was saying, okay, the various methods, you can add, these methods will be determined as part of the development process. There's a difference between not having a plan and not being able to be at the part of your development where you have the detail. But yeah, have as much detail as you can. Even if you're not sure, these factors may change. Now at the end, you want your software design document to match the actual software. So you will have to go back and edit stuff. And basically they start to describe a queuing simulation in here. Here's some good stuff. The simulator will assume that each launch will hold the maximum number of people. Error factor sets up, right? So that's a good thing. So they're talking about rides like Pirates of the Caribbean, where they fill a boat up and then they launch the boat. Simulator allows for control over the launches of the attraction in the form of a time function, as well as an error factor. So it sounds like they're going to have a basic range of times by which these rides go out. Every X seconds a ride goes out. We assume that the ride will hold the maximum number of people. These are good specific things. Option to temporarily stop and resume the attraction. Speed of the simulator is selected beforehand. Now we could actually take that's good stuff. Now if that student wanted to get even better, they could say, here's the ride. It's a typical ride with a boat launch, and the traversal time of the boat through the ride is 12 minutes. And the goal, you launch a boat every 10 to 15 seconds or 30 to 35 seconds. Each boat holds 12 people. Now you've got a real clear definition of what you're going to try to code. You may not have that level of detail in your head yet, but I'm trying to push you to be there. Now notice it doesn't have to be right. Like this person doesn't have to accurately model a specific ride at Disney, but it's the same kind of ride, right? They all operate the same. They've got a boat, they fill up the boat, they launch the boat. If they wanted to do inheritance, maybe they have another ride. Some rides are more continuous, where there's just a constant row of cars going by, and you step onto the platform and step in, right? They're continuous rather than these launches. But either one has the basic properties of people being fed through the system and people arriving at the system. And then you can start to play with, okay, what happens if we have a delay of 2 minutes on a boat because someone, some baby got sick or something like that. You can play games like that with this simulation, but the point is you can try to specify as much as possible. I like the language here. The more I'm looking at this in terms of how I'm trying to get you guys to do stuff, the more I should take it out of the good example, maybe. Let's try one more, and then I want to hear questions. Let's see, what's this one? Common schedule generator. It's in the format, that's good. This is a program that finds shared free periods in multiple schedules in order to make it easier to determine the best time for a specific group to get together. Do you guys have a good idea what this project is based on that first sentence?
Yeah.
Yeah, I think it's great, yeah. If there's no, they even have a backup plan. If there's no common free time, program will suggest times that work for the greatest number of people. It's basically, they're doing doodle poll, right? Program generates a basic schedule. Now notice, I don't think there's any references in here, but this would be a case where this person probably didn't need any references unless they wanted to reference, you know, doodle poll or something like that. No need to. Generates a basic schedule that be manipulated by the user to create their personalized schedule. Basic schedule is a template containing each day of the week and a block for each hour within a day. See, I'm getting some detail here. I feel like I know what's happening, because certain times are likely unreasonable to meet during, like very late at night or early in the morning. Users are able to select an acceptable time frame and program will omit 8 hours out of it. Okay, so that's, I like the detail of that. I would, the sentence is a little bit clunky, but that's fine. The detail of this is good. Users select as many time frames within a desire to represent where they are busy, which is then saved in a new schedule. This can be done for as many users as needed, with a new individual schedule saved for. Okay, so what do you think? I think this person's got a pretty tight description here. Notice it's not that big. I think this is one of the rare cases. It's remarkably short, but I think it pretty fully describes the functionality. Now, one thing that they didn't mention here is users. You probably need to have a way to, you don't necessarily need a password, but you need a way to log in or identify your users. That's not listed here. But I'm convinced that this person has a very clear idea of what the functionality that they want to build. And they didn't lock themselves into a design. They didn't say that the schedule is going to be presented in a specific way. They didn't say that the manipulations are going to be done using a button. So they've left that open to the design portion. So if you're worried about, man, this thing looks awful short, there's no way Garfield's going to accept it. If you've convinced me that you've actually described with good detail about the functionality of the project what you're doing, then it can be short. Now, I think their solution section will be longer because, you know, what they're describing is may not be easy to achieve. One thing I can't remember with this program is how they got inheritance. I don't see an obvious use of inheritance in here. Okay, let me open up for questions here. Are you concerned about what I'm looking for?
Do you have any examples for the agile tracking sheet?
Just the one that I had that I shared that I made. It's included in the things that I shared online.
Okay.
Yeah. Yeah, this is the first semester I've done that way. So I don't have a previous semester examples for it. But there is one online, and we talked about it last time. We can talk about it again in a little bit. Okay, so then you might be asking, oh my gosh, how do I get here? How do I write this stuff? Here's my general advice for how to write something. I've been looking at the very fine-grained stuff right now. This is after after the sentences are written, and you can look at them and see if they make sense. But prior to that, that's another skill. It's a different kind of hardness. Here's my recommendation. Just draft out, after somebody reads my document, what do I want them to know? If you keep asking that question, after they read this, what do I want them to know? There's one of the reasons, at the beginning of each lecture slide series, I have those outcomes. You know why we have outcomes? That's for me. That's much more for me than you. I make all these outcomes first. What do I need you guys to know? And then I make sure that my slides and lectures actually talk about those outcomes. Whenever they have, they teach professors how to put classes together. And whenever they do that, one of the first things they say is, you need to make a list of course outcomes. When the students are done, what do they need to know? So I would just ask you to approach your writing that way. At the beginning, that introductory thing, what do we need to know? We need to know what you're doing and why are you doing it. If you've answered those two questions, you're good. You might want to throw some context in there just so that in the problem description proper, the context doesn't muddy up the words. And then you say, okay, in the problem description, what do I want my reader to know? What do I need to get out of this thing? If anybody reads it, what should they know? They need to know what your project is at the top level, but then remember, they're going to ask, you've done this. If you bought a phone or if you bought any kind of a device, what do? Well, can it do this? Can it do that? Does it support this? Does it support that? Right? As a consumer, that's how you choose how you're going to buy things. And so imagine someone is going to be asking that about your project. Well, will it do this? Will it do that? Will it do this? Will it do that? And be clear about what it does, as clear as you can be at the time. And then everything that you haven't listed by default would be off the table. So for example, let's take this person's schedule maker. And every time this particular group of people want to get together, the schedule maker, they go through the schedule maker and they all find, basically they all take the doodle poll and then they all find times. If they did that over time, it's likely that there would be a couple of time slots that they would all tend to meet in. Right? If I have 5 people and I say, okay, on Tuesday we're going to meet, when can you meet? And they all say 3 o'clock. And then next week we do it again, they're probably going to say 3 o'clock again. Right? It's not 100% guaranteed, but it's likely. So one thing that we could add to this project is learning, machine learning, where over time it will suggest to you times that are going to be most likely ahead of time. Now, this person didn't list that, so I don't expect that to happen in this project. Be kind of a neat project. But you can think about, okay, does this thing learn over time? No, because they didn't tell me about it. They did tell me, I think I'm pretty clear about what it does. I don't think I have too many questions about what about this, what about that. Oh, here's a question. What if I do time preferences? Maybe there's 3 different times of the week that the group can meet. but maybe we could put a time preference system in here. And then of those three, it would pick the highest group preference. No, I don't think it does that because it didn't say that. But think about that. Ask, does it do this? Does it do that? Now, you're going to be lousy at asking that question probably, because if you have your own idea for a project, you probably already are thinking about, okay, how is it going to look at the end? Most of you guys have a really clear vision of what it looks like at the end. I would recommend that you take your project descriptions and show it to somebody else and have them ask you, well, wait, does it do this or does it do that? What if you did this, right? And that way you might find where your descriptions might be a little less clear than you thought they were. So that's how I get down to when I'm writing, I start out with, okay, what do I need people to know? And then I start organizing into, okay, problem description. This is pretty short, right? It's just describing, literally just describing the project. And that's fine, you can do that. I would say any background information that you need prior to the actual project description, I would put up front in the introduction. So here you are describing your project description, and then you start to organize, okay, what do people need to know? Usually once you get your list of what do they need to know, let's say there's 5 things, you can look at that list and say, okay, if I start talking about number 3, will they even know what I'm talking about? No, I better start with number 1 first. People need to know that first. Then they can talk about number 3. Then they can talk about, right? That'll give you a sequence, and that will lay out your flow of how you're going to write this stuff.
So looking at this document a little longer, it kind of looks like they only describe it from a user standpoint view. Is that all right, or do we also?
Yes, that's correct. Yes, yeah, that's right. So they're going to describe you're going to describe it functionally. And when I say functionally, I mean how does it function? And it's the user who's most interested in how it functions.
So we're not necessarily caring about what classes and stuff that we plan
exactly
on
because that's design, and we don't want design. We want a description of behavior.
Okay.
Right. Good point. Now in the P3, that's when you're going to get into that. Oh, how did it do these things? I'm going to have a separate object for each, in this case, a separate object for each user and a separate object for each schedule. I'm going to have file IO. I'm going to let people, pick and choose which files they're going to bring back into the system when they want to find the combined schedule. That kind of description of how. What are the classes and how do they work? I need to get rid of that one. Let's see. Let's try. Here's an average example from the final report, Zombie Infection Simulator. So this is going to have the P2 in it also. Introduction. Project will be a zombie growth simulator based on entered values for initial population of infected, armed, healthy, unarmed, healthy people. Stop right there. Do we know what it is? After that first sentence. I think I've got a good idea of that. Okay, and then we say the GUI will visually display the total population representing each entity as an image. User will also be able to save and name data. Okay, and then look at this. Here's why simulators can be easily adapted, such as spread of cancer spells or growth of an invasive species or an ecosystem or viruses in a computer network. I think, let's see, oh, look at all this stuff here. This is why armed people use their weapons, and look at all this information. Oh my gosh. When you're doing all this information one after another in paragraph form, my recommendation, that's where a table would work out great. Right, what do we have here? Pistols are considered bases of comparison, have average range and accuracy, deal out 2 hit points. Shotguns have lower range, accuracy, 3 points of damage. Large sticks have low range, high accuracy, deal 1 point. That's a table right there. Now notice they didn't say what low, medium, and high range are yet. If you have fully developed your game, you would include that. And otherwise it would be something like, you know, as part of the game development. But I think we could have, you know, you probably could have done that. Large sticks, that has a range of 6 feet. Shotguns have a range of 30 feet. Pistols have a range of 50 feet. I don't know. Something like that. There's no references for how pistols and shotguns and large sticks behave because they're not actually trying to do a real world simulation, right? I've had people try to do simulations of combustion in a barrel of a gun, and they had to use a lot of references to get the details right. They do give some information though, right? They move at the same and will die when they have 0 of 2 hit points. Okay, so there's, you know, there's some design going on here. Again, I would say here, each type of enemy, regular zombies, armed people, unarmed people. We have, and I think we have the unusual zombies too. That would be another table. Your writing gets easier when you put that kind of detail in a table because you can say, you know, give the table a name, table 1, table 2, refer to table 1. Movement of the different characters is per table 1. Health and damage allowed for each character is a table 1. You can do that kind of thing. The GUI displays a grid map of all entities, real-time population and time, which is adjustable speed. User timer continues until the simulation is ended. And then all it is how population and resources affect the spread of it. It's not very long. Now, the reason it's not very long, I think one of the things that they, let's see, did they give all the description of each game will be every entity individually moves, uses a weapon, or picks up a weapon? I guess they can drop weapons too, I don't know. Fairly simple description. I think it's, I don't know, ask the question, does it do this? Does it do that? I think I'm confused. I don't know if zombies can use weapons or not. I also don't know, can an armed and unarmed people, can they switch roles? Like if I'm armed, can I drop my weapon? If I'm unarmed, can I pick up a weapon? It looks like I can pick up a weapon. So I'm confused. I'm a little confused about how this person would control the, oh, here, somebody comes armed with contact of a dropped weapon. I'm a little confused about how they're gonna study, say, the impact of how much weaponry is available, right? The percentage of armed and unarmed people. I think the information's here. Let's see, are there obstacles, like are there walls or anything like that? I don't think so, right? It's not listed, so I'm assuming no. So this is a fairly short, again, a fairly short description, but you know, you can have a short description if it's complete. I don't know, you guys think I'm wrong about this being complete? I could be wrong.
So because it doesn't say anything about how it's displayed, is that a lack of information or is that just something that they've chosen not to do yet?
Well, we know this. Where is it? Represented on a GUI which displays a grid map of all entities according to population. So the way I'm reading that is you get a top-down view of the map.
Okay.
It probably would be a good idea. It doesn't sound like, it sounds like this is not something you participate in. Like you're not a player in the game running around, right? It looks like it's just a simulation that gets set up where there's populations of zombies and people, and you just hit the go button and you watch it play out. That's what it sounds like to me. That should be maybe made more clear. But I think what I'm saying here, since they're saying that it displays a grid map of all entities according to population, that language is a little clunky. I think it's just displays a grid map of all the humans and zombies would be good. So it does have the functional description of what the map is going to be. Now, it would be a little too far, I think, to say zombies will be red circles and people will be blue circles.
Like that's just into design.
That's design. That's
okay.
Right.
For the next project deliverable, I guess P3, will we have started to learn Java FX so that we can talk
Yeah,
about
we'll get
more
into
design?
Java FX. Yeah, we'll get into Java FX at that point. So you'll have some time to think about how that's going to work. But, you know, ironically, FX is probably the most annoying part of your project, the hardest to work with and to code, but the least important in the sense that your real, you know, this real simulation, the simulation is under the hood, right? It's all the classes that you never see. You've got to have an object for each zombie and an object for each human. And remember, once you throw it, you can run that simulation without a GUI at all. The GUI is just showing you the results. So remember, I'm going to keep pushing you to get rid of this idea. If I'm looking at the zombies on the screen, those are not the zombies. Those are a representation of the zombies. So oddly enough, in terms of the simulation, the GUI is the least important part, but it's the hardest to, it may be the hardest to actually program because, you know, GUIs are always just frustrating.
Yeah, that programming part is what I'm worried about because I want to be able to design it with enough foresight that it's kind of easier on that aspect.
Okay, so you see, I'm trying to push you to be very rigorous in your writing, but you're seeing by these, that doesn't mean you're going to come in with a 10-page report. Right? These half-page, I think, you know, for a moderately complicated project, I think 3/4 of a page to 2 pages is probably about right, just for the text. What's this one? This one's got, what, including the introduction, yeah, a little over a page, right? And it would be longer if they didn't need any references here. It would be a little bit longer if you were doing something that that required references. So I know a couple people are doing like the elevator simulations. Well, they need to pull in some queuing theory and they need to pull in some statistics and stuff like that. Some people are doing physical simulations. You know, you might want to throw some, by all means, if you're doing a physical simulation, throw a diagram in there. This person could have even thrown in a diagram top down of the GUI and said, this is a notional idea of the GUI. It may change, but you know how that works. When you're talking to a picture, it helps. Now this, you know, that's an option for this one. For some, it really helps if you draw just some kind of a diagram to describe what you're doing. It may or may not be your GUI. It's okay to have a notional idea of your GUI. It's just, don't lock yourself into a design yet. All right, we're at time. Nice to see you all. See you on Monday. Oh, terrific. No, you do not. You do not. And in terms of getting references and stuff, now you can go bug him, right? You can get the references from him. All right, take care.